Okay, this is Lab 1 Introduction. What I'm going to do is I'm going to show you how to be able to do your breadboard lab. And the purpose of the breadboard lab is to understand how the breadboard's laid out. And essentially, the blue line and the red line here are what's known as the power rails, and the power rails supply power. So in other words, I could put one wire in there anywhere along that rail, and it would power. So if this is coming from a battery, it would power all that entire rail up. And then I could take, I'll use a little 9-volt snap connector. So for example, if I put my connector on here, and I had a 9-volt battery attached to it, I would be able to power up the entire rail. So I've got in here, I've got my little power connector that would snap onto my battery, and then that in effect would power up this entire rail. So it would power up the positive all the way across and the negative across on the blue. Notice that there's another one over here, positive and negative, and that there's a bridge in between. That bridge separates these two boards. So with these power rails, there's continuity this way, there, and there. And this is the breadboard portion where you construct your circuits. These are not, they don't go this way, they're not connected this way. These are internally connected this way. So these 5, and these 5, and these 5, and these 5, they're all connected. They're the same potential, they're the same point. So the purpose of the breadboard lab is to understand how these are connected. So what you're supposed to do is with your meter is you're going to put this onto continuity. And that's the continuity setting there. It looks like a little Wi-Fi symbol that's turned sideways. And it's also, that's your diode function as well. And what you're supposed to do is put your two leads together and you'll hear it ring. So you can hear it ring. The problem is that the lead points on these are not pointy enough to be able to get actually in into the metal. You really have to push hard, and it doesn't really want to make a connection. So what I do is I just take a little bit of that wire that you got and fasten it on like that. And then what you can do is you can just take your readings like this. You know, you want to go from here to here. Okay, well we know we have continuity. Go from, say, here. If I want to check to see if I have continuity or a connection point to the next one, to the one to the right of it, I'd put it in there. Oh, it's not ringing, right? So I'm going to put it to the one beside it, and it's ringing. See? And this one's going to ring, and that one's going to ring, and this one, and this one. So all these 5 are a connection point. And you're asked in the lab to find out what is connected where. And it says A, B, C, D, E, F, G, H, I, J, hopefully on yours, and then K, L, M, and O, I believe. So if you're looking for the K, L, M, and O, they're on the power rails themselves. So to give you an example, if I was to go check, okay, well, how far does this power rail go across? Well, I could go, okay, so it goes to there. Goes to there. In fact, it goes all the way across. Does it connect to the red rail? No. Does it connect to the blue rail up here? No. Or the red rail, or any of these others. So the blue rail and the red rails only power up to themselves. So if I wanted to check, is there continuity from, let's check from A10. So that's A10. And I want to see if I have continuity from A10 to E10. So there's E. So I'm going to go over to 10. There we go. So you get a little bit of connection, and we can hear that it's ringing. So I know I have continuity. And all continuity is what it does is it tells you that there is a circuit there. There is an ability for current to flow.